Hi everybody, Mrs. Pesic here. We are finishing our look at section 2.5 from earlier today. In this example, we're going to find all of the real solutions of this function. It's a cubic function, so you know we need to find 3 zeros altogether. And so if we want to find the solutions, we are going to need to start with making a list of the possible rational zeros. So if we're going to make a list of possible rational zeros, that's supposed to say rational, use your imagination. All right, that means we want our list of P over Q values. All right, so the P values are going to be the factors of our constant term. So that's going to be plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. Those are all the numbers that divide into 14. And our Q values are going to be all the factors of our leading coefficient, which is a 1. So that's just plus or minus 1. And let's not leave it looking like that. Our full list of possible rational zeros is going to be us taking every numerator over every denominator. So that's going to be 1 over 1, 2 over 1, 7 over 1, and 14 over 1. So altogether we have 8 possible rational zeros. Remember, these are just possible. Doesn't mean they're guaranteed. And so what we're going to do now is we will graph this on our calculator and see where we see it crossing through the x-axis. So let's try that. I'm doing x cubed minus 7x squared, x cubed minus 7x squared. And what was the rest of it? Minus 11x plus 14. Minus 11x plus 14. All right, so there's our graph. And so what I'm noticing is it looks like that the graph is crossing through at maybe -2 here. If I'm looking at that. So let's try -2 in using synthetic division. So I'm going to make -2 in the box, and I'm going to put our coefficients, which are 1, -7, and -11 and 14. And doing our synthetic division here, I bring down the 1, multiply, I get -2, add, I get -9, multiply, I get 18, positive 18, add, I get positive 7, multiply, I get -14, and we do get a remainder of 0, which means that this function has, means this function here, which can be written as x, let's see. So our function can be rewritten in factored form as x plus 2, since a -2 worked in the box, times what? Well, remember, this is your clue here as to what the other factor is going to be. So that's x squared minus 9x plus 7. All right. When we look at the graph, though, do we see where it crosses through anywhere else? Well, if you look at, I can slide this out of the way. It does not look like it's crossing through at 1. It looks like it's a little bit less than 1. And here, this looks like it's, let's see, 1, 2, 3, 4, 5, 6, 7, 8, a little bit more than 8. Well, those numbers are not in our list. So I think we have real zeros, 2 more real zeros, but they must be irrational zeros, not rational zeros. So what we're going to have to do to find those zeros is set both of these equal to 0. Well, when we set x plus 2 equal to 0, we get x equals -2, but that's not a surprise because we did synthetic division and saw that that worked because we got a remainder of 0. So with this one, we can try and do product sum. Product would be 7, sum would be -9. I don't think there's any way to get that to work. Product sum is not going to work. So we're going to need to do quadratic formula. So remember, we've been starting to write this as -b over 2a plus or minus square root of b squared minus 4ac over 2a. So in this case, our a value is 1, b value is -9, c value is 7. So when we plug this in, trying to plug this in, we're going to get Opposite of b, so it's going to be a positive 9 over 2 times 1 plus or minus square root of negative 9 in parentheses, very important, squared, minus 4 times 1 times 7 all over 2 times 1. So I'm going to get a 9 over 2 plus or minus square root of 81 minus 28. And all of that is over 2 as well. So 81 minus 28 on my calculator. 81 minus 28 gives me 53. So back here, I get 9 over 2 plus or minus square root of 53 over 2. I don't think that can be simplified, so those are our two other solutions. So if we're going to list all of the zeros, all the solutions to this equation, we'll get, it was negative 2. Yep, it was negative 2 would be one solution. 9 over 2 plus or minus square root of 50. Let's see. Back. Let's try this again. Erase, erase. I just want to write this as, so I want to write this as 9 over 2 plus square root of 53 over 2. That's one solution. And then 9 over 2 minus square root of 53 over 2. So that's how we get the 3 zeros for this function. So in this case, I just want to kind of highlight what we've learned. We have taken this function, and we know it's a degree 3, so it's guaranteed to have 3 zeros. Remember, they might be real, they might be imaginary, they might be repeated, but there's going to be 3. And out of the 3 zeros, we found out that one of them was, all 3 were real, right? All three real zeros, and we saw that because it was crossing through our graph in, where's my graph? It was crossing through our graph in 3 places, but only one of those real zeros was rational, and the other 2 were irrational. So this was the, the rational 0, and these 2 here were irrational, but all 3 were real. All right, let's see, one last thing to talk about. Complex zeros occur in conjugate pairs. So that means that if a plus bi is a 0, if a plus bi is a 0 of the function, then a minus bi is also going to be a 0 of the function. All right, and we actually saw that happen in this last example because we have, actually we didn't have complex zeros. Let me rephrase. So if a plus b is a 0 of a function, a minus b is a 0, but I think that would also work with, if you have a plus, square root of b, then a minus square root of b is also going to be a 0. So let's take a look at this last example. So in this case, we have find a 4th degree polynomial function that has 3, -1, and 2i as the zeros. So it's supposed to be a 4th degree polynomial function, so we know we're looking for degree 4, but we only see, 3 zeros here. But remember this rule that if you have a complex 0, right, that they're going to occur in conjugate pairs. And we do have a complex 0 here of 2i, so that means that 2i is a 0. You could think of it as like 0 plus 2i if you'd like, and that means that 0 minus 2i is also going to be a 0. So of course I don't have to put the zeros in there, so I can just say that my zeros are 3, -1, 2i, and -2i. And we're supposed to write the function, so if these are the zeros, then let's write what the factors would be. So if 3 is a 0, then x minus 3 is a factor. If -1 is a 0, then x plus 1 is a factor. If 2i is a 0, then x minus 2i is a factor. And if -2i is a 0, then x plus 2i is going to be a factor. All right, and this really is our function, so I can just write, hey, this is, this is f of x, but we should probably write this in standard form. Let's multiply it out. I would suggest that we multiply out these first. So let's use FOIL on that. So we'll get x squared for the first terms. Looks like a plus 2ix for the outer terms, minus 2ix for the inner terms, and then a minus 4i squared for the last term. And these guys here are subtracting off, and I squared is equal to -1. So I think we're going to get x squared plus 4. Let's now take a chance to multiply these two together using FOIL. So if we do that, we get x squared. Outer terms would be a plus 1x. Inner terms would be a minus 3x. And the last terms here would be a minus 3. And if we combine like terms like we have here, we'll have x squared minus 2x minus 3. But don't forget, that's still got to get multiplied by our x squared plus 4, right? So we really need to multiply these guys together. I personally like the box method to do this. So you remember we did this way back in the appendix. So I'm putting, what, x squared plus 4 here. And I'm putting x squared minus 2x minus 3 here. And now I'm multiplying to fill up the boxes. So I get x to the 4th minus 2x cubed minus 3x squared, 4x squared minus 8x minus 12. And so in this case, I can combine any like terms that I have and say that my function is going to be x to the 4th. Let's see, I've got a minus 2x cubed. These guys are like terms, so I can say plus x squared and minus 8x minus 12. So there's our function. And if you wanted to, graph that, I think you would see the real zeros are occurring at, 3 and -1. You could test it, and then you'll end up getting your 2 complex zeros if you work it out the rest of the way. All right, so that's it for this video. Thanks for watching.